of the concepts related to activators and MEMS. Now it's time for us to invite the resource persons of technical session 3, Mr. Kishore Kumar, who is going to speak about activators and MEMS. Now I invite Mr. Kishore Kumar sir to take this session. Thank you.
Hello, sir, am I audible?
Yes.
Yes. Thank you.
You can start now, sir.
Yes, sir. Sure. Just a minute. So some of the topics has been left on session 2. We will continue from there. So is my screen is visible, sir?
Yes, sir. Yes.
Okay. Okay.
Now you are in interfacing ultrasonic sensor. Am I right?
Yes, sir. Yes, sir.
Yes,
Yeah.
sir.
Okay. From session 2, we stopped from ultrasonic code. So for another time, I explained the code, how code has been written. So we all know ultrasonic has 4 pins. So VCC, ground, trig, and echo. So VCC is for 5 volt, ground for ground. So trig means directly connected to a GPIO pin, and echo means it is used to receive the signal sent by the trig pin to find the distance between the object. So trig pin is an output pin, so we don't need for any voltage divider bias for the trig pin, because the data need to be sent from Raspberry Pi to ultrasonic, so it is not needed. But for echo pin, we need to fetch the data from outside environment via sensor to Raspberry Pi. So we all know that GPIO pins defaultly act as both input and output pin. So and also it also operates at a 3.3 volt. So we need to step down the voltage to 3.3. So we go for voltage divider bias. So we use two resistor, 4.7K and 10K resistor. So using these formula, the voltage divider bias, we can able to step down 5 volt to 3.3 volt. So then the echo pin has been given to a GPIO pin. So I showed you at morning how it has been connected in my device. So this is how it is constructed. So at coding purpose, first we need to import two import function. First one is RPI.gpio function for including the library for GPIO. So we need to create an object for GPIO as GPIO, so that we can able to access that library and the functions inside the library. Then import time is one another library in which we can able to access the functions like sleep, wait, some other functions in time. So then the third step is we need to set the mode BCM. We need to set the GPIO mode so that we can able to access the GPIO pins, all the pins, trig and echo pins, all the pins, all GPIO pins. So we need to give the GPIO set mode GPIO.bcm for any coding. Whenever we use GPIO pins, we need to insert these three commands. This first library is important. Secondary, whether we need a delay, we need to import time. Otherwise, import time is not needed. But import RPIO.gpio as GPIO is important. Whatever name is suitable for you, just give us as object name. Here I am giving GPIO, so it is easy to access. So whatever name is convenient for yourself, so please give the name. Then we need to set the GPIO.set mode. Whenever we need to access that GPIO pins, we need to set the mode first. Then I'm creating a two global variable for trig and echo, so that whenever I change the pin, I just change the values in that variable. So trig is 23, GPIO 23, and echo is 24, which is GPIO 24. Then one print function, distance measurement in progress. So then we need to set, once the set mode is set, the GPIO starts to work. But Raspberry Pi didn't know which pin is input, which pin is output, because each pin acts as both input and output mode. So we need to set that function. For that, we use GPIO.setup. So setup, inside the setup, pin comma mode. So pin means the pin number which is declared. So 23, instead of 23, we are using a variable name. So trick has been given here, comma mode, which mode it is, whether it is an output mode or input mode. There are two modes only. So GPIO.out means output mode. So the data has been transferred from Pi to ultrasonic sensor, whatever sensor they need. And echo pin is for input pin. So GPIO.in. So echo pin fetches the data from outside to Raspberry Pi. So this is how it works. So then we are going to, after these basic setups, we are going to trigger a pulse from ultrasonic. Raspberry Pi sends a pulse via ultrasonic to the outside environment. So we are generating the pulse inside our coding. So we are generating a pulse from one full pulse, one positive cycle, one negative cycle for 10 microseconds. So for that purpose, we are using GPIO.out output pin comma value. So value is false. So while false means 0. So first of all, we need to set the position before starting the pulse wave. So we are going to set the value as false. So it starts from 0. So from 0, one positive cycle, one negative cycle for 10 microseconds. So after 2-second delay, here only the pulse gets started. The GPIO.output tick comma true only the pulse gets started. Time sleep is 0.00001, which is 10 microsecond. 1 means 1 second, so 10 microsecond. GPIO.output trick comma false means one positive cycle for 10 microsecond and one negative cycle, so the pulse gets stopped. While sending this, I am also measuring the time based on the value of the echo pin. So whenever the echo pin receives 1, the pulse gets ended, which is pulse gets received. Whenever it gets 0, pulse is not gets received. So I started, whenever the trick pin triggers the pulse, I just started the time and store it in a pulse start variable. And whenever the pulse is received, the echo pin changes to 1, which the time is ended. So I store the time value in pulse.in. Okay. So I can have it. I'm having pulse start and pulse end. So based on pulse duration, I'm just rounding up the value, so that start and stop time based on that. So I'm getting a time. So for distance, we need a speed equal to distance by time. So distance equal to speed into time. We have time in pulse duration variable. So we need speed. Okay. So speed means defaultly speed of sound in air is 343 meter per second. So we need to convert it centimeter per second because we are measuring in centimeter only. Okay, so converting 340 meter per 343 meter per second into centimeter per microsecond, we are multiplying it with 100, so that it is converted to centimeter per second. Thus, distance equal to 17150 means we are getting a value both from transmit one point to another point, and next the pulse gets reflected and reaches the same point. So it has two time value. So from one point to another point, then another point to same point. So that's why we're dividing by 2. So we get only the point started to the point end to the object. So that's why we are dividing by 2. So we are getting a time. So speed into time equal to distance. So that's how we are using distance equal to pulse duration means time into speed. So we are getting a distance. So distance variable, it stores a distance. So I'm just rounding up with the distance comma 2 means just 2 decimal places, so that I can get the value slightly precise. So after that, I'm just checking whether the distance value is within the range or not. Whenever it is within the range, within 2 to 400 means the range is between 2 to 400. So the value is slightly precise. Okay. So I'm printing the distance value. If not, it is an out of range because the maximum range of ultrasonic sensor is 4 meter. So other than 4 meter, it just sends the garbage value. So it's not accurate. So maximum range of sensor is 2 centimeter to 4 meter. It is the range of the sensor. Precision means 0.01 precision. This ultrasonic sensor we have used having. So this is the code for ultrasonic sensor. I will show you the connection at morning session. So I can just show you another time. So this is how we connected. So am I visible? So this is how I connected. So ultrasonic sensor. So 5 volt trig and ground must be directly connected to ultrasonic Raspberry Pi, and echo pin is used to connect via voltage divider bias. Okay. So I'm connecting the 5 volt, which is green wire, to a 5 volt of Raspberry Pi. 5 volt is the first pin. Whenever you cross check the GPIO header, you can able to see that. So 5 volt. Then 20 GPIO 23 and GPIO 24 is trig and echo, and ground pin ground. So this is how I connected. We just started from here, this notch. So whenever the camera is connected, you just started to calculate from that point. So that is a 1, 2, 3, 4. Okay. So I'm taking 5 volt, ground, GPIO 23, GPIO 24, which is 8th pin and 10th pin. So this is how I connected. You just verify. So this is the starting point. So I connected the 5 volt at pin number 2, which is 5 volt, and then pin number 16, which is 8th pin from right side, which is GPIO 23. This is the point where trig pin is connected, and next is 18th pin. 18th pin is GPIO 24, where I connected echo pin, which is the output from the voltage divider bias, mid place from the voltage divider bias, where the two resistor is connected parallelly, sorry, seriously. So 18th pin is a echo pin, and then ground is when whichever ground you need, you just plug it to a ground. I connected to a 30th pin. 30th pin is a ground. So this is how we connected, and this is my code. So I will show you how to type the data inside the file, and also how to run the code. Okay. Just say I have already written the code in Raspberry Pi. So if you want to create a new code, you just go for any notepad file. So here I'm using leafpad. So just so here I'm using a leafpad as notepad. Okay. So is it visible? So you can type this code here. So whatever the code you needed, you just save it. So I already typed the code. Just open it. So this is my ultrasonic code. I'm just opening with the leaf pad. So is it visible now? So is it visible? My code page. Okay, thank you. So this is my code page. Okay. So here I'm typing the code. So import rpa.gpio as GPIO. So this is the library we need to import it for time. So whether you need to specify more precisely, you just import this function directly. If you don't need to import all the function from time, if you want sleep function only, you just import time from time, import sleep. So this is one of the function. If you want only the sleep function, so other than that, if import time, only import time is given, it is not an issue. So you can able to handle it. Then I need to set the mode. So GPU.set mode, GPU.BCM. So you know BCM. So BCM are the broadcam. So which are the pins? We need to set that mode for accessing the GPIO. So it has a trig and echo pin. So trig 23 and echo is 24. So then GPU.setup, we need to set up the mode whether the pin is act as input or output. So here GPU.input as GPU.in for echo and GPU out for trig. So see the indenting, so how the code is indented. So this is how the code should be properly indented. If indenting is not proper, it won't work. So please be careful with indenting. So each editor has separate type of indenting. Sorry, Arduino Uno code means. So if you want Arduino Uno code or what are you asking, sir? So I didn't get you. Arduino Uno code is not available. No, code structure is same for all the things. So I just convert and write it in Python, the ultrasonic code. So whenever I just run the while loop, so just start the trig pulse. So waiting for the sensor to settle. So same GPU input trig true. So time sleep is 10 microseconds. So GPU.out just pulse. So one full pulse from positive to negative, it gets executed. So I'm just starting start time and stop time has been calculated, so I can get the time. So once I get a time, based on that, I printing the distance. So this is how I print the distance. So just save it as file, save as whichever path you need. So I'm save it in. So the code is inside a py folder and codes. So codes inside that I'm storing ultrasonic.py. So this is my code. So this is my path. Okay. So after the code has been written, we need to execute the code. So BCM means Broadcom mode. So it is used for what enabling the GPIO pins. So for Arduino itself, the structure will be same. So this is how, right? Just be some of the syntax and names will be different. Functions has been different compared to that. But structure of the code for Arduino and Raspberry Pi is same. So So I written a code as a structure in Arduino itself. So we used to work in Arduino also. So the structure will be same for both. This is how the code works in Arduino also. So I can able to change it because it's a Python. That's C. That's the only difference. Other thing, all the structures has been same. Please look. So okay, after code is written, you can save it a path. So then we need to run the code. So after connecting it, so just open the LX terminal. So this LX terminal is visible.
Yes, sir.
Okay. Okay. So now for running the code, for executing the code, we need to access the file path. Okay. So I'm storing the path in py/home. So which means /home/py/codes. So in that folder only, I'm having the code. So we need to traverse to the that path. So cd space /home/py/codes. So if the path is not um, existing, it shows this error. Okay. So whenever you store it on desktop, you just given us, if you give cd slash space tilde symbol, it removes from all the path and comes to a starting position. So if you want to move to a desktop, cd space /home/py/desktop. So this is the path for the desktop. So I'm storing the code in home py/codes folder. So this is my path. So I move to this path. So my file name is, look at here, ultrasonic.py. Okay. So for executing, so whatever the version you have, just whether it is a Python or Python 2 or Python 3, the command will be Python space filename.py. Please store save the file name with the .py extension. So that's how Raspberry Pi gets executed whenever you execute using Python keyword. So please store it in .py extension. So Python. So here I'm using 3. So Python 3 space file name ultrasonic.py. So whenever I place my hand, the distance gets varied. So 4 centimeter, 3.9 centimeter, 3.0 centimeter. So look at this. Whenever there is an error or some other malfunctions gets, the value should be in garbage value like this, because I am rounding off to 2% only. So this is a wrong value. So whenever you close a sensor or the sensor is in out of range. So in here I didn't mention the out of range condition. I just printed the distance itself. So whether you need to eradicate the garbage value, just mention the range properly. So this is how it works. So whatever the structure you want to print using distance, you can able to change inside the code. So this is how all the codes has been executed. So if you want to stop the process, you just click Control C. So the path gets interrupted using keyboard interrupt. So it is a default catch in Raspberry Pi. Whenever you gives Control C, the process gets stopped. So whenever you need to traverse to a starting position, cd space and tilt symbol. The above tab there is a tilt symbol, shift plus tab. CD means it's come to a starting position. Then you traverse to whatever the position you need to move. Wherever you store the code, you can give either Python 2 or Python 3 with whichever version has been installed from your OS based on the command pip packages you install. So whenever you give a wrong file name, like so whenever you give a wrong file name, so there will be an error. So there is no function or the file or directory is no. So whenever you give proper name, so the code gets executed. There is no issue. If you want to stop it, just give Control C. So this is how the ultrasonic sensor is interfaced and work. So any doubts in working of ultrasonic sensor? So any things you needed? What are the things? Are there any things you need to repeat in this session? Uh, Specific in ultrasound? Anyone? So any queries? Use multiple ultrasonic sensor. Yeah, sure. We can able to use multiple ultrasonic sensor in this file. But we have only two 5-volt port. So maximum without sharing the voltage, you can able to use two ultrasonic sensor. If you use n number of sensor, we need to plug the 5-volt to a breadboard and we need to share the voltage. But there is some issue with sharing with the voltage. So please check whether the voltage is properly given to an ultrasonic any sensors you interface, whether it gets 5-volt or not. Can able to interface in number of sensors. So any other thing? So any doubt in code? Yeah, there are many sensors. So I'll look through it. Some of the vendors at morning session, some of the person asked. So I saw some of vendors like Bosch, then Siemens, um, and some other two companies. So they are providing sensors based on high precision. So we can able to get it and we can able to interface with the Raspberry Pi. So it's so their sensors there is more precision and also it covers more distance compared to this ultrasonic. For testing purpose or for the mini projects also, we can use this ultrasonic sensor. Some other things we can go for their industry. So anything? So any doubt in code? So I can able to show only one sensor only. So please, if you have time, you just work it, and if any issues or errors, you please ping me back or contact me through me. So any other thing. So any issues. So any queries on this session? See, other than CD prompt means there is some. So I can show you some other application. So like LeafPad, there's a Gronny ID journey. So it's like an IDE, so you can able to code inside that directly. So it's at loading. Yes. See, this is one of the IDE, so we can able to use. So this is some other code I have written before. So it is an ultra. It's not an ultra string code. So it is using MQTT. So you can able to what, import libraries, and we can able to use this kind of IDE also, other than CD-ROM. But it is good to use CD-ROM. So any issues it can given directly instead of using third parties IDE. So any other queries on session 2? So anything you need to repeat on session 2? Yeah, compared to Raspberry Pi, Arduino Uno is cheaper. So Raspberry Pi is 3,600, Arduino Uno is 550. So compared to it, cost-wise, it is efficient. So, but for if you want to transmit the data, so that is the main issue. So whenever you are going for Internet of Things, the main part is connected to internet and just pushing the sensor data through Wi-Fi to. So any other user, if you are working in a company, you are doing a product, so you need to connect to internet defaultly and just push the data. So whenever you go for is fine, but instead of Raspberry Pi, whenever you get you need to buy another Wi-Fi device for transmitting the data through Wi-Fi. So Wi-Fi device is mandatory. So it costs around 400 something. So ESP8266 like Node MCU module. So it is one of the one. So compared to it, you need to add some other things, and also the main problem is power issue. Arduino operating voltage is 5 volt, but Node MCU is operating voltage 3.3 volt. You need to connect both into a power source, and you need to power that power source using an adapter. So that way, cost wise, it goes on 2,500 around. Whenever you construct a product other than ultra sensors, if you go for sensors also, it costs us around. So more or less, it comes around 2,000, 2K. If you're doing a project using and what Wi-Fi all the stuff. But 3,600 means if you have a SD card, HDMI cable, all the things, the price gets lower. So based on the newer version, the price gets higher. But SD card and HDMI cable, it costs around 500 to 600. So if you already have these things, you don't need to buy the thing. So it comes around 2,500 to 3,000 only Pi board. Yeah, Arduino is user friendly, but while coming for industry, Raspberry Pi is more efficient compared to Arduino. But Arduino is user friendly. You can be able to see. Only configuration purpose only Raspberry Pi looks weird and complicated, but working style both will be same. So from my experience, I am telling I didn't know. So I worked both in Arduino, Raspberry Pi used to work with. So from my purpose, both are equal. But it's C language, so everybody knows C easily compared to Python. So we need to study. So that's the main issue I faced whenever I used to work with it. So any other questions? So session 3, it took only half an hour. So I just give the basics, and after that session, you just ask what are the doubts and queries you need. So we can discuss it. So before closing the session. So So this is the step for execution. So I told you. So here I typed the steps. So above code, typed in a notepad and save it with the .py extension. so that whenever you execute it from the command prompt, it get easily executed. Whenever it's in any other extension, it wouldn't be able to access from command prompt. Whenever you giving Python command, so Python space .py extension will be executed. So then open the Windows terminal, traverse to the file path and execute Python space Python or Python 3 file name .py and click enter. Your code will be executed. The output will be like right hand side. So you saw the output. So this is how the output shows. So what are the things you need? Whether you need to change the format of the output, you can able to change it. So whatever things you need, you can just. So indenting is the only issue. So please take care of it. So session 3 will be actuators and MEMS. So it's an half an hour session, so not big deal. So I couldn't able to give a hands-on for this. So but I can give the code and structure how to code it. So you can try it, and if you face any issues, you can ping me. So mainly actuator. So actuator is like a component of a machine that is responsible for moving and controlling a mechanism. So actuator means just a mechanism to move. It is one of the component in a machine. So you can able to move the thing inside the machine. So for example, DC motor, stepper motor, you see any of the motors. So DC motor, stepper, servo. So any type of thing, it's an actuator. So based on the electric signal you given, the shaft gets moved. So um, the rotation has been done. So n number of applications you see using DC motor, stepper, and servo. These are the basic actuators, and all three has been interfaced using Raspberry Pi also, Arduino also. So all the things has been easily interfaced. So, but we need to drive each and thing. If you just pick the DC motor and just give the supply to positive, negative, negative, it rotates in a clockwise. So whenever you change the uh, yeah, I just took an example for DC and stepper, just an example only. So ABS also can actually. So okay, if you give positive to positive, negative to negative, so the DC motor rotates in clockwise. If you switch on and change the rotation based on supply, it gets rotated in anti-clockwise direction. If you want to drive any motor, you need some of the driver IC. So driver IC is the main thing to drive the IC. So whatever the signal you passed, you need to write a condition. So it need to rotate in a clockwise. So whenever you need, you can't able to switch it to a positive to negative, negative to positive, so to rotate in a clockwise and anti-clockwise direction. So we are using drivers to control actuators actually. So for DC motor, we use L293N driver. So N all the drivers we can able to use. For stepper motor, we use ULN driver. So other driver is convenient for you, so you just use it. So each motor actuators has different libraries. So okay. So each actuators had different libraries for executing. So stepper motor has stepper library. So you can't doesn't want to write all the stuff. So you just import that library and access the functions inside the library using a dot function. You know. So like your time GPIO library function. So then main thing is relay. So relay is the main thing now industry has been used mainly for switching purpose. So um, whenever you are connecting 220 volt to 240 volt, so any thing in our house with the controller. So you can't able to connect directly to the controller because controller is a DC. In our home, all the things are AC, so we can't able to connect directly. So for that purpose, we are using an electro coupled switch, so electromagnetic switch. So relay acts as an electrically operated switch. So it is an electro switch. It has two modes, NO and NC, normally open and normally closed. So based on the supply, we can able to switch the mode. So it converts a 220 volt step down and convert it to a DC. So can able to connect both the AC on one side and DC at another side. So It's easy to communicate with the controller and the things which are interfaced in our home appliance, all things, and also in industry. So relay plays a vital role for connecting this. So this is the major thing. So for every smart home appliances, relay is a major one for switching purpose. So here I didn't mention about what, driver. So I didn't use driver. I just take an example of rotating the actuator DC motor directly connected to a relay. It's a 12-volt relay. So I'm uh, I'm connecting 12 volt to one side. So I'm just powering the relay. So at the other side, I'm connecting with the microcontroller. So 5 volt ground and signal pin. So 12 volt is used to, it's a 12 volt DC motor. So I'm providing a 12 volt. So one end is positive and another end is ground directly connected to that. So another end is given to a, and left side is NC for a relay. So I'm connecting NC or NY, any other thing with the positive of DC supply, and another end with the DC motor. So we can able to switch that based on the switch N1. Normally it is in common. Whenever I pass the signal as high, the switch gets close to a motor, so the motor gets powered on. Here I didn't rotate that clockwise or anti-clockwise. I am just rotating it at one direction. Okay, so this is how connected. So you can use the driver, so L293 driver, to drive the motor at both clockwise and anti-clockwise, whichever direction you want. Just rotate it based on that. So this is a simple structure of DC motor based on just switching on and off and rotating 12 volt DC motor. So this is the code I have written. Okay. So here I'm using same. So import RPA.GPIO as GPIO. So I'm importing GPIO library for accessing that, and import time for delay. Okay. So here channel equal 21 means it's a variable name. So I'm using GPIO 21 for connecting the relay. Okay. So next, whenever we use GPIO pins, we need to set the mode. So GPIO.setMode equal to GPIO.BCM. So in this code, so I'm writing a main function. So here if double underscore name double underscore double equal to double underscore main. So this is the main function. So Python is an interpreter language, so it gets executed line by line. So if I mention the main function here, so the execution starts from main. So if you mention this, if you didn't mention main function, the execution started from start point, channel, GPIO, set mode, setup, then to function. Okay. So here I am writing a main function. So the main function gets executed firstly. So inside try, I am writing motor hyphen on channel. Channel means here I am channel is 21. So my pin number. I am just calling this function. So here I am writing two functions. Def motor hyphen on. This is one of the function where I passing the pin number. So another function is motor hyphen off pin. So these are the two functions just to on and off the motor. Okay. So I'm just passing the pin number to that function. So inside the main, so it starts call this, or you can write directly this condition inside the main function. So it is easy to write. Yeah, I will provide the PPT. No, not a PPT. I will provide this as a document to you. So within today or tomorrow, I will send the concerned person. They will. Okay. So 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 based on the main function, the loops gets executed. So the function gets called and the execution process is done. So this is how the relay is switched on and off between a DC motor. So I'm just powering on and off. If you want to drive the motor, you need to connect the L293N driver. with this DC motor. Instead of relay, we are going to use driver, whichever we want. L293N and D, both drivers has been allowed to use. So you can use whatever the driver you need to buy. And then you can write the code to drive the motor. So this is how it works. So this is one of the example actuator. So that's how it works. So any doubt in this program and connection? So any queries, any doubts? So there are many functions using this DC motor and what stepper motor and servo. So based on these three functions, many of the things has been done. So in industry 4.0, mainly motors has been the main function. Driver and relay. No, not needed. So here I'm just driving the what switching on and off using relay because it is a 12-volt DC motor. So I can't able to connect directly the 12-volt DC motor to a Raspberry Pi. If it is a 5-volt DC motor, I can insert the 5-volt directly using a voltage divider to a GPIO pin and then ground to ground. So I can able to on and off the DC motor directly. So here I am using a 12-volt DC motor. So I'm just showing how to connect 12-volt DC motor with it. If you use a driver, it's not an issue. You can driver is a 5-volt driver only to communicate with controller. So another end will be 12-volt. So you can directly couple the DC motor with the driver and install. Oh, virtual Raspberry Pi, I think so. Virtual Raspberry Pi is not that much efficient compared to working in real life because power issue will be main. So it's easy to code, but it's hard to connect and communicate the components correctly with the Raspberry Pi. So instead of virtual Raspberry Pi, it is good to work with Raspberry Pi because majorly whenever I used to work, I faced the power issue only. So I can able to interface 5 to 6 sensor, but main issue is the sensors can't get proper power supply whenever I'm using controller. So I need to go for another. So if you worked on virtual, it means you directly connect all the sensors with one common power source, so you can't be able to find where the loss will be. You can't able to know. So that's the main reason instead of using virtual. Like I didn't use virtual Raspberry Pi, but I can search and tell you there is available. So, okay. so so this is the code of DC motor. So just a brief about MEMS. So then you can ask for whatever the questions you need. So just basic MEMS. So MEMS is nothing but a micro electromechanical system. So it is used to allow that to construct a mechanical structure into a miniature size. So it can able to communicate both the mechanical and electrical circuit. So in IoT, MEMS plays a vital role in industry. So you can able to communicate with both the mechanical and electrical system. It's like a small system. Okay, you can able to construct what are the mechanical structures you can able to construct in a small size, miniature size, and you can able to communicate with an electrical circuit. So it can be switched on and off and can be controlled easily compared to the mechanical machines. So that's how MEMS used. Here we used to verb the machine to describe the work of a tuning piece of metal. It is a mechanical, like a gear or pulley. But in MEMS, we are creating that process by rotating a gear or pulley. For that purpose, we are constructing a small chip. Small chip has been constructed miniature circuit, and it can be connected with the IC, so it can be easily electrically communicated and controlled easily compared to gear or pulley. So that's how MEMS is used. So this is one of the cantilever switch beams. So this is how the cantilever switch beams. So it is an internal structure. So this conveys a physical structure of a cantilever switch beam. So there are 4 switches, each of which has 5 contacts. So here are the contacts. So the switches are activated by the applied voltage. So whenever the voltage is applied, the micro machined cantilever switch beams can be turned. So it is used for automatic and the automatic rail um, rail tracks. So it can be considered. It's a miniature of it. So you can able to do that processing here. So like a miniature circuit using a silicon fabrication, all this stuff. So this is one of the MEMS device. So here it is a MEMS switch. Okay, so it is an RF MEMS switch on the right side. It is associated with the driver. So this is a switch on the right side. So on the left is a driver circuitry. So based on this driver circuitry, the mechanical switch has been controlled based on that. So based on the voltage given by the circuitry, the switch acts. For example, you take a relay. So it's one of the MEMS device. So you can able to communicate both the things. So some of the examples of MEMS are there are many 4 categories in MEMS application. So audio, sensors, switches, oscillators. So audio means there's a MEMS speaker and microphone. So small piece of microphone. So in olden days the microphone will be large. So now it is becoming miniature due to MEMS. It plays a vital role nowadays. So MEMS speaker also the speaker size also reducing. So the function of a large speaker has been handled by small. Then all the sensors, so all the sensors has been one of the application of MEMS only. So for example, take gyroscope, inclinometer, accelerometer, flow sensor, gas sensor, pressure sensor, and magnetic field. So all the sensors have been example for MEMS. So each sensor works differently. For accelerometer means you can go for vibration sensor. Flow sensor means you use to control the flow. In gas, in petrol stations, all the things we can use flow. And gas sensors, we know how where to use gas. Pressure sensor. So pressure sensor, flow sensor means these sensors used in ventilator purpose. So for oxygen controlling, so all the purpose we go for flow sensor. Pressure sensor is used to pressure how much oxygen can be given to a patient. So it can be used and automatically. So these sensors measured. So then we saw switch like MEMS switch, RF MEMS switch. So it is one of the switches and also oscillators. So these are some of the MEMS application used to work. So nowadays MEMS play a vital role. So all the things has been a miniature. So there is a communication between both mechanical and electrical things. So it is easy to handle for the person. So what are the things they needed, they can be easily communicated and done. So this is how MEMS works. So thank you. So any queries? What are the things you needed? You just ask me. So yeah, half an hour. What are the doubts you need to ask? You just ping. So okay. So whether I need to give any overview or whether I need to give any repetition of PPTs. So what are things you needed? Just ask me.
Participants, if you have any queries, you can share your questions. Sir, is there any website to practice on virtual Raspberry Pi?
Sir, I can search it and give. Sir, I didn't work in virtual Raspberry Pi, but I can search it and I will tell you, sir, once I do.
Okay.
Because without checking, so whenever I get the call, it won't work. It doesn't do. So I can check it and work it, and I will ping you.
Okay, sir.
So any other things you need to ask? Any other doubts? So for which execution, sir? For Raspberry Pi or Arduino? Because one person asking about Arduino. Which ID do you want to know?
Which ID, sir?
For Raspberry Pi. So for Raspberry Pi, the ID is there are many ID defaultly available, sir. So like
Okay.
Tony ID, then just a minute, sir. So I will show you. See, sir, Blue Jay, Genie, so Greenfoot, and Tony Python IDE. So whatever IDE you use, you can also use to execute for Python code. You need to check in um, Anaconda, Spider. So Spider is good for Python coding. For Raspberry Pi, you just use this IDE. So these are the IDE preferable. So there is no some other IDs. Weather prediction system is interested. Sure, sir. Yeah, we can able to make the weather prediction. So Google provides some of the basic APIs, free APIs, which is used to cloud APIs, free APIs to transfer the data from what, IoT device to a person place through Wi-Fi. So they default have API. If you want to create your own API, you can able to. We just connect the sensors with the Raspberry Pi and just code it and fetch the sensor data and push it using IoT Hub, Azure IoT Hub or some other things. Or whether you having a cloud database or you need to transfer within your center, you can able to use MQTT protocol. So based on MQTT protocol, you just push the data to MQTT protocol. And in C Sharp, Visual Studio, there is a defaultly available MTMQTT library and MQTT.NET library. So I can able to fetch the data from MQTT protocol easily. So fetch the data, you can process the data based on what are the data you have given. So it is a full processor from scratch itself. You can able to build your own weather predictions. Which one, sir? Raspberry Pi supports Python only, sir, not embedded C specifically. So Python would be better compared to. If you know well versed in C, you can go for Arduino, sir. So Arduino is not an issue. So if you well versed in C, you can use. Embedded C means you can go for pick controller, whether whichever you are strong, sir, you can go for controller. Controller is your purpose. So whatever the controller you need, you can choose based on your purpose.
Sir, if possible, can you share any recently developed IoT, what you call applications developed by user?
Um, yeah, sir, but it's without permission. I can't able to show, sir. So that's
Okay.
why it's not.
Okay.
So I asked sir to tell you about something.
Okay. No, no problem.
We are now working in Industry 4.0. So many other projects has been in pipeline. So it is not without
Okay.
permission. I can't able to show things.
Sir, you can at least share your experience in working with developing IoT applications.
Sure, sir.
What are
Actually,
all the
actually,
problems
yes.
you have faced in your development stage?
Yes, sir. So mainly, I want to thank you for all the people to listen to my lecture because compared to you, your overall experience, I am a student of you all because all the person has been doctorate. So if in my session, based on what I learned, so I just shared it. If it is any mistake, you please bear with me so I can change it. So it's not an issue. Okay. So working in Linux or Windows platform, which is better? No, sir, both are same. But just now, what machine learning and artificial intelligence came into existence. Sir. So other than IoT, AI and machine learning gets overrated, and also big data analysis. So whenever we go for AI and machine learning, Linux would be better, sir, because Python is the well-versed code for machine learning. So other than Windows platform, Linux would be better, sir, for machine learning. Machine learning is the future. Security issues means based on the protocols. What are the protocols you used? They faced many issues. So that's are the major issues we faced. Security issues mean. So we used MQTT protocol. So mainly using WebSockets. So WebSocket is a secured. So we have some WebSocket particular port for accessing it. So based on the WebSocket, we used MQTT protocol. But other than WebSocket, if you use MQTT protocol in some other ports, it is an open port. So whichever the person is able to hack and take the data. So just now we started to work in Azure IoT Hub. So just now building some of the things. So a lot of the things I have faced. So because whenever I started my career, so IoT is new to me. So from college itself, I didn't well versed in coding. So just now started. Some protocol use UDP. Yeah, sir. So yes, AMQTT used advanced MQTT message queue transfer use UDP. Sir. CoAP use UDP. CoAP constraint application protocol. So it used UDP, but we use MQTT, so it is a TCP/IP protocol because it's a public subscribe protocol. But if you want CoAP, you can use CoAP. So it is an UDP protocol. So any question?
Sir, what about the issues in UDP?
So compared to TCP, UDP is a quite slow process. So you can't able to transfer a large number of data properly. So we need for a proper gateway. So compared to TCP. So whenever we need to send a small message, it's a last process compared to TCP. No, sir, we didn't use UDP so because we mainly worked in MQTT protocols only. So in MQTT it is a TCP/IP. We doesn't go for UDP. So I didn't know much about UDP.
Sir Kishore, sir, still we have another 25 minutes. Can you conclude your what you call all the three sessions,
Sure, sir. Sure.
but simply recall all the important
Yes,
points?
sir. Just 5 minutes. I can take whether any other questions or none. So then I can conclude all the sessions.
Any questions, please? Nothing. Okay.
So okay, I can give an overview about what are the sessions we have got from morning itself. So So we saw Raspberry Pi. So Raspberry Pi is nothing but a low-cost credit card size computer. So we can able to plug and play what are things you can do with your CPU. So you can able to connect the monitor, mouse, keyboard, and you can act it as a separate computer. So you can able to do what are the steps you can do in laptops and desktops. Like you can able to play games also. So you can watch videos, spreadsheets, word person, coding, storing all other things you can able to use in Raspberry Pi. So it is one of the best controller compared to other controllers because it has defaultly many features like camera, and also it is faster compared to other microcontrollers because the other microcontrollers are 8-bit, 16-bit, so it is an 64-bit. So it is quite faster compared to that, but it is not quite good compared to computer. It's a light miniature computer, so you can do what are the light steps you can do. It also RAM, so it has Wi-Fi and Bluetooth, inbuilt Wi-Fi and Bluetooth port. So I didn't show you how to change the password, how to enable SP and I2C communication. So I just show you how to. Just open the LXT terminal. So is it visible, sir? Command prompt. So is command prompt is visible? Okay. So just type sudo config. So you just go ahead and go for it. If you want to install any other software, new software, whether you need it, you just go for add or remove software. So what are the things, what are the IDs you need, what are the programming languages you need? So documentation. So each has different type of software. So you can able to use what are the things you need. So one of the main feature in Raspberry Pi in latest version is Scratch. So Scratch is one of the latest version. So it is used for artificial intelligence. So Scratch is one of the thing in Raspberry Pi. So this used to code easily. So this is one of the main feature which is evolving Raspberry Pi for the last 2 years. So we can just drag and drop it and just run it. So it is easy to code for the kids all the things. So this software is one of the main thing covered by Raspberry Pi Foundation, because their main goal is to uh, teach the programming to the kids itself. So here the kids will be easily able to code what are things. If they need to move the cat, they just move it in step and just play. So just give the cat name, just drag and drop looks motion. So what are the things they need, just drag and drop it, and they know how to code. They didn't need to know the structure of the code. They basically need to know how to drag and drop. Cat need to move 10 steps, so just drag the move on 10 steps. So after 10 steps, you need to rotate it. So if it reaches the end of the screen, it needs to restart from start itself. So these are the conditions. So if they need condition, they go for conditional statement. So they search for condition. So in condition there is a if. So they drag and drop if. So they can able to easily think and drag and drop. They didn't need to go and know the syntax, how syntax has to be written. So they doesn't need to know all things. So this is one of the features of Raspberry Pi. So one of the main software. So then, so here the Raspberry Pi configuration settings. So you can able to change this. Just a minute, it's loading. It's still loading. So just so in this Raspberry Pi configuration file, we can able to see what are the configuration, how to enable I2C SPI. So if you use SD card reader and NFC, other things, so they are SPI communication. So we need to first import the SPI communications, and we need to enable the configuration file based on the Raspberry Pi configuration. There is an advanced setting. So inside that, what are the protocols we need? Whether it is I2C or UART or SPI, we need to enable it each condition inside this Raspberry Pi configuration settings. So it's loading. So just 2 minutes. So I will show you once the thing is completed. So this is the features of Raspberry Pi. So these are the external things. So it has 2.4 GHz WLAN and Bluetooth also 4.2 BLE. So it also has an Ethernet port and 40-pin GPIO header for interfacing the sensors inside it. And it has a HDMI port. So using HDMI port, we can able to connect with the both monitor and also separately with the monitor. So it acts as a separate computer, and also can able to connect with the laptops, and using SSH we can able to enable it. So it has a micro SD slot and also a separate touchscreen display. So touchscreen displays are a separate thing. So Pi camera also, it doesn't comes with the default kit. Only the controller only comes for the price. So these are the things we need to buy it separately. Power source, display, camera, what are things we needed? We need to buy it separately. So they didn't come as a package. So what are things you needed? You just want to buy it separately. So setting up a Raspberry Pi. So just burning the OS. So once the ISO image has been downloaded from raspberrypi.org, we need to burn that ISO file inside the SD card. So we just plug in the SD card and format using any SD card formatter app, and then burn the ISO file inside the Raspberry Pi. So based on the Balena etcher, here I use Balena etcher, so you can able to use any of the ISO burning, OS burning image application to burn the image inside the SD card. So once the OS has been burned, you can remove the SD card and you can plug it in the Raspberry Pi. And there is a two ways to run the Pi. One is via monitor and one is via SSH client. If it is monitor, you can directly connect the HDMI to a monitor and keyboard and mouse. So the Raspberry Pi gets booted defaultly. If you want to do SSH client, so if you want to run it in a laptop itself, so we can able to enable SSH, and also we need to provide the network settings once the OS has been burned. So we go for this command. So echo k:/SSH to create an SSH file without any extension. So once this file created, we need to provide the network settings. So based on WPA supplicant.configure.txt. Yes, sir. Same, sir. So, if you having a desktop, so desktop has a monitor. Whether the monitor has an defaultly provided HDMI port, you can directly connect it to an without connecting a CPU. You can directly connect the HDMI cable with the monitor, so you can able to easily view it. If you want to view via desktop, so including CPU, so you can do the same process. So you can need to do this network settings and also all the things. So what are the network it need to be connected, and what are the SSH need to be enabled, and you can be able to view it in SSH. So monitor means you can, if monitor is separately you have, you can directly connect it to it. If it is a desktop or laptop, you need to connect through an SSH only. So WPA supplicant.conf.txt file is a text file. First, you need to create a text file and just need to mention what are the network settings you have provided. Based on the priority, the network setting has been taken. So if the SSID has been connected. So after that, you just remove the TXT extension and save it as wpa-supplicant.conf only. So whenever the Raspberry Pi gets booted, you just look for SSH and also WPA supplicant-conf. So after that, you just unplug the SD card and plug it in a Raspberry Pi and connect the power supply and the HDMI port to a Raspberry Pi and connect the HDMI port to a laptop and just boot it. So after booting it, use advanced IP scanner once the IP has been found. So based on the name, it has Raspberry Pi at mshome.net. So it is a default name for any Raspberry Pi. Instead, you didn't change it, it will be same. If you change the name, it will be what the name you have been given. The name also has been changed, and also login ID password can also be changed. I can show you how to change it. So, okay, so this is the IP. So whenever you found the IP, you can able to log it to SSH. So there are many SSH software. So here I am use Mobile XTERM. Mobile XTERM is one of the software. So using Mobile XTERM, I can able to log into it. So based on the IP address, you can able to give the IP address or the name Raspberry Pi mshome.net. So opening the Mobile XTERM, the window will be like this. So click the session. So one session setting gets open. So click the SSH and provide the remote host. What the host name, whether host name or host IP, and just give OK. So the Raspberry Pi gets booted. So login is defaultly Pi and password will be Raspberry in small case only. So once this been given, the Windows been started, and whenever you give start LXD, you can able to launch the Pi. So the Pi application looks like this. So this is how the configuration settings. After configuration, you need to install basic installation. So we need to install Python packages from pip and dev, and also we need to install GPIO packages. So these are the key packages basic. So sudo apt-get install python-pip is one of the package. So it install the latest version. If you are using Python 3, you just give Python 3 instead of Python. So it is one of the steps. So for dev itself, same Python 3-dev. If you use Python 3, so what are the latest version Python? You can able to give. So if you want to know which version of Python is installed from default use Python space -- version. So it can give the version of the uh, Python you are using in Raspberry Pi. For enabling GPIO, sudo pip install rpi.gpio. So you can able to initialize the GPIO pins. What are the pins you need to? So once the GPIO is installed, you can able to access the GPIO pins. So you can able to integrate sensor with it. So these are the basic installation. So this is the GPIO 48 pin. So the pin number is differ from the GPIO pin. So whenever the pins you mentioned in Raspberry Pi, those are GPIO pins, not the uh, pin numbers. So GPIO is the pins you mentioned in your code. So please be careful while writing code. You can give the GPIO pin. So whichever pin you needed, you just cross verify and communicate it. Just uh, start the position from camera. So sorry, display slot. So opposite display slot, you just start to 1, 2, 3. So it has 250, 3.3, and also 7 number of ground. So whatever ground you need, you just use it. So it can able to use SPA, I2C, and also UART communication. So whichever communication you want, what are the modules has been connected, you can use whatever things you need. And then sensor. So we saw what is the difference between analog and digital. There are some of the sensors we saw. So vibration is one of analog, ultrasonic is digital, touch is digital, smoke is analog, so temperature analog sensor. Magnetic wave is digital, soil moisture is analog, so PER is digital, IR is digital, RFID and humidity. RFID is NFC, humidity sensor is analog. So it is one of the vibration sensor used to detect vibration. So it only has 3 pins, so you can able to connect directly to a Raspberry Pi. Then ultrasonic sensor, we interface the ultrasonic sensor, we write a code and we work with. So touch sensor, it's one of the digital sensor, so it gives value either 0 or 1. So based on the voltage value. So you know how the voltage has been internally calculated inside the Raspberry Pi based on the formula operating voltage of controller divided by how many bit ADC you can use to power in with 8-bit ADC means 2 power 8 256. So 256 equals to 0.019 value. So whenever you give 1 as a value to an analog, so it takes us 0.09 volt. If you give 256, it converts it and acts as a 5 volt. So whatever the numbers you give, it acts as an analog. So this is how it works. So that sensor, smoke sensor, MKD sensor. If you want to detect, one of the person asked morning how to measure the hydrogen inside the soil. So I searched it and I saw there is available of hydrogen sensor. Hydrogen sensor is used to measure the hydrogen molecules. So whether it is available in water, air, and also soil, we can able to interface it. So you please check it. So how to use the hydrogen sensor to find the hydrogen present in the soil. So one of the questions. Then temperature sensor for low precision we use LM35, for high precision we use Omron thermal sensor. So based on the purpose we can use. So magnetic is one of the digital sensor. So it is used to it acts as a magnet. So north and south pole attract each other. Another switch close the value will be 1. Open means 0. So based on the purpose you can able to use it. Soil measure works on Ohm's law, so it gives a resistive value. So R equal to V by I. So whenever the current is low, water content is also low, so the resistance will be I. So based on that, it works. So inversely proportional current and resistance. So based on the water content, the current and resistance acts as the voltage will be default. It will be 5 volt. So then PIR sensor, so passive infrared sensor, it is used to detect the motion of an object. Still object can't be detected, so it is a limitation of PIR sensor. IR sensor means it is used to detect the objects whether the object is in motion or whether the object is stable, we can able to find it. But black object can't able to detect, so it is a limitation of IR sensor. Then SD card reader, it is one of the SPI communication, so we can able to store the data. What are the data you need to write a file or what are the things you need, you can able to use it. Then RFID reader is one of the NFC tag, so near field, it works 3 to 5 centimeter maximum. So it is one of the SPI communication also. So it is used to connect with the sensor and Raspberry Pi, and we can able to tag. Only drawback is if you are using an admin system using RFID, so you can't able to find whether the particular person only enters the ODC or not. So we can't able to find using RFID because if your friend is having this RFID, they tap it. So that means will be for you also, whether you are present or not. So it is a main drawback of RFID. So that's why in nowadays we are using fingerprint sensor. So fingerprint sensor, each fingerprint is stored with some ID. So whenever that fingerprint is readed, so it gets cross verified and that number has been stored for the attendance purpose. So humidity sensor, it is used to find both temperature and humidity in environment, not in soil. So in environment. So we can able to interface it. It has a DHT11 library. So based on the library, we can able to add it. So interfacing ultrasonic sensor. So using voltage divider bias, we can able to connect the echo pin because echo pin is 5 volt. We for all the GPU was 3.3. So you can able to connect using a voltage divider bias. The code is same. So connection will be here. So we see trig, echo, and ground. So trig is directly connected. VC also directly given to 5 volt. Ground is connected to ground, but echo pin is connected by a voltage divider bias. So this is the code for ultrasonic sensor. You just write a code in a leaf pad or any other notepad and store it with a .py extension, and you just traverse to the path where the file is saved and give a command as in a LX terminal, traverse the path and just give the command python space filename.py. So it gets executed.
Sir, a small announcement, sir.
Yes.
Now the participants are able to raise their queries by unmute their mic. So we made that provision so the participants can raise their queries by unmute their mic and can interact with our resource person.
Yes, sir. Can we use noobs? Yes, we can use noob OS also instead of Raspbian OS. So all are same. So you can install and use whichever OS you want, either Raspbian or noobs.
So I wanted to know whether because I have already installed actually, so I already have the setup. So can I go ahead and do all those things that you explained today?
Yes, sir. Yes, sir. You can just try it. Sir. It's not an issue.
Okay. Thank you, sir.
Okay.
Any questions from audience? Any questions? Shall we wind up the session 3 now? Any feedback? Participants are free to express your feedback of day 1 session. You can unmute your mic and then speak. Right.
Okay, sir. I wanted to speak something on this.
Yes, sir.
Can I go ahead, sir?
Sure, sir.
Yes.
Yeah, last session that sir actually talked about. Can't we have a hands-on like on this actually, like on memes and etc.? Then would that not be possible at some time?
Yes, sir. I tried to give the hands-on in any of these sessions. So I try to make it, or I can add it in a document and I can share the document so you can able to.
Yeah. That would be very nice, sir. Fine. Sir.
Okay, sir. So I can able to add it in a document and I will show you before this Friday workshop has been finished.
Okay, sir. Thank you, sir.
Sure.
Any other questions? Okay. Shall we wind up the day 1 session now? Right. So on behalf of Sri Ramakrishna Mission Vidyalaya College of Arts and Science, the AICTE-ATAL sponsored FDP on IoT, I wholeheartedly thank Mr. Kishore Kumar DP for providing 3 wonderful lectures on various topics of IoT. Really, I will appreciate Mr. Kishore Kumar's work today.
Thank you.
Once again, I thank Mr. Kishore Kumar for his wonderful contribution to IoT Day 1 session. Thank you.
Thank you, sir. Thank you, sir.